Good day, everyone, and once again we're back together. All right, so I usually hear people saying that there's a bit of a challenge when it comes to these organic reactions, right? So I thought I'd just take this question, all right? It's one of the prelim questions from last year. I hope it will help, in addressing this challenge. So they say the flow diagram below shows different organic reactions, PQ and R, which are organic compounds, right? So they say reaction 1 is an addition reaction. Now, I want to quickly just go through this, right? So if we look at compound Q, right, it reacts with bromine, okay? And in this case, we end up with 1,2 dibromo, meaning both the molecules, or rather both the ions of bromine actually attached themselves to this compound, okay? So now I want you to note that can only happen if we had a double bond, right? So which means that compound Q is definitely an alkene, and definitely this would be an addition reaction, right? If it was an alkane, what would have happened? Only one of the bromide ions would have actually substituted one of the hydrogens. Okay, so definitely we know in this case that we have an alkane, right? An alkene rather, for compound Q. Now, they say name the type of addition reaction. Now, we added bromine there, so this would be halogenation, right? But if you want to, you can say this is bromination, okay? So we are adding brown bromine there. Right, now they say to us one observable change which occurs in the container during the reaction. Okay, one observable change would be the rapid decolorization of bromine water, right? So bromine water is usually brown in color, and so when it reacts with an alkene, it rapidly decolorizes, as opposed to when it's reacting with a saturated hydrocarbon, which is an alkane. It would only decolorize slowly once we put it in the presence of UV light. We would need an external source of energy. Right, now they say to us the structural formula of compound Q. Now, how are we going to know what was compound Q? It's everything that we have except the bromides, right? So except the bromos. Okay, so in this case, I'd remove the bromos, so which means we had 2-methyl, but now note it was an alkene, so in this case, it means that I would need to put a double bond somewhere in the mix, right? So we've got our hydrogens over there, all right? And I know I would have an alkene, so actually I should get rid of one of those there. So we've got hydrogen there, we've got hydrogen, okay? What I would need to do, okay, so yeah, this would be incorrect, right? So with the double bond there, okay, so this would be, right, there we go. Okay, right, so this would be 2-methyl, right? Propan 1-ol, right? I mean, prop 1-ene rather, not propan 1-ol, right? That is 2-methyl propan 1-ene. Okay, prop 1-ene rather. Okay, so this is what compound Q would look like, okay? Right, now they say to us, consider reaction 2, write down the IUPAC name of compound R. Now let's go to reaction 2. Reaction 2, what we are doing is that we're taking that alkene there, and we are reacting it with hydrogen chloride. Now please remember, and they say to us we are forming a major product. So please remember, Markovnikov's rule would apply here, and Markovnikov's rule applies when we've got hydrogen with another ion being added onto an organic reaction. Okay, right, now please, I want you to note in this case, so according to Markovnikov's rule, the hydrogen would go to the carbon that has the most number of hydrogens, right? So yeah, man, I did say there's something that looks odd there. I think I added one more hydrogen over there, right? So what would happen in that case? It means we're going to break that double bond, that second pi bond, right? And that means hydrogen would go to the carbon with the most number of hydrogens already. So what you would have, in fact, let me just redraw it like this. Let's say the hydrogen is this side. So the hydrogen that we would add, we would break this double bond, right? And it would make two arms available. So hydrogen would go to the carbon with the most number of hydrogens, and therefore chloride would then go to this guy here. Okay, so that's how we would form the major product. Okay, so they say write down the IUPAC name of that guy. So this would be 2-chloro, 2-methyl propane, isn't it? So this would be 2-chloro, 2-methyl propane. In fact, maybe let's write it at the top there. So that's 2-chloro and 2-methyl propane. Okay, right, please remember that. Okay, now for reaction 3, they say write down the balanced equation using structural formulae for the organic compounds. Right, now in reaction 3, ladies and gents, what we're doing is we're taking that haloalkane that we've now formed, right, in reaction 2, and we are now going to convert it into an alcohol. And remember, to do that, what we usually do is to react it with a dilute strong base, right? I did say in my video that this is one of the most popular reactions that they like, okay? So dilute strong base in this case would give us an alcohol, whereas if we use a concentrated strong base, we would get an alkene, right? So now what we're going to do is that the hydroxide ion from the sodium hydroxide would substitute the halogen, okay? And that's how we're going to form the alcohol, right? So let's write down the reaction. They said in structural formulae. So remember, we had the CH3 over there, okay? We've got the halogen, which is the chloride ion, okay? All our hydrogens in there, okay? And in this case, this is what we have, right? But now what do? We react it with sodium hydroxide, and I did say to you, this is going to form, or the hydroxide ion is going to substitute the chloride ion. So I'm going to form OH over there. Okay. So we've got that alkane, or rather ethyl, methyl group there. Okay, that side chain that formed. And everything else is just hydrogens, right? Now, please remember what has happened. The hydroxide ion, we substituted chloride, okay? And now we're left with sodium with the chloride ion, so which means our byproduct in this case would be sodium chloride. Okay, I hope that makes sense. Right, so that is how the cookie crumbles there. Right, so let's go on to the next one. They say the IUPAC name of the alcohol. Now note, we've got the hydroxide at carbon number 2, we've got a methyl group at carbon number 2. So this is going to be 2-methyl. Okay, so that's 2-methyl. The carbon has got 3 carbons. So this is propan 2-ol. Okay, right. So that is what we formed there. Now they say reaction 4 is an elimination reaction. Now please, I want us to note what reaction 4 looks like. Right, so reaction 4, we take the alcohol and we are now going to convert it back into becoming an alkene, right? You remember compound Q was that alkene there. So before we added anything, this is what it had, that pi bond there, the second bond, right? So in this case, what we're going to do is we're going to have to eliminate from the alcohol the hydrogen as well as the hydroxide ion to form that, right? And usually what we do to do that, we react it with either sulfuric acid, okay, which is a dehydrating agent, or it could be even phosphoric acid, okay? Right, so that would be the reaction there. Right, and now they want us to note that, right, they said write down the type of elimination reaction that it is. So we're eliminating HNOH, which is water, and this is dehydration. Okay, so this is dehydration. All right, now the next one, they say butane 1-ol reacts with propanoic acid in the presence of a catalyst. Now remember, anytime we take an alcohol with a carboxylic acid, we are going to form an ester, and we do that in the presence of sulfuric acid as an acid catalyst, right? Now they say write down the type of reaction that takes place. That's definitely esterification. And finally, they say the IUPAC name of the organic product that is formed. Now, please remember that whenever we form an ester, right? When we name an ester, we always start with the alcohol side first, right? And in this case, that's going to be butyl, okay, butane. So that's butyl. It tells us that we're not done naming. And then the carboxylic acid side, that is propan, and the suffix for esters is always OH. So it's butyl propanoate. Okay, right. I hope that makes sense, ladies and gents. And of course, I'll keep throwing now and then some revision questions there so that we can look into the different sections. Otherwise, from me for now, I'll see you guys again next time. And please don't forget to subscribe. Sharp, sharp.